everyone. My name is Prescott Watson, and as you just heard, I'm here in the Bay Area working with Edgybees. Our motto is enabling the best decisions at critical moments, and we're all about improving the interface that human operators have with the information that's being presented to them when they're making mission-critical decisions. I want to talk about two things today. The first might be something you've heard quite a bit at AWE, and the second is our proprietary information about what we're doing today. The first is our vision for why augmented reality is going to be a critical component in the world of technology as it pertains to how humans are going to interface with the world around them. And the second is what we're going to do about it. So bear with me as I cover a lot of things I think people have discussed today here at AWE. Why augmented reality is going to become so important. There are a confluence of trends that have been happening in the past few years that are overwhelming human operators, but that pose a great deal of advantage to humans in the future if we have a better way to interact with the information coming out of our systems. The first is that there are a tremendous number of low-cost, high-quality sensors that are pervading our world. Everything from smart materials to smartphones to IoT sensors. The amount of information being generated by systems today is unprecedented. And when you combine that with connectivity and edge intelligence, what you're seeing is that the infrastructure that builds our cities and our communities is actually beginning to have a level of awareness that it didn't have before. This is a photo of a smart camera released by Microsoft and Qualcomm last week that has the ability, because of a Qualcomm chipset and some Microsoft AI frameworks, to decide when to begin streaming video to the cloud based on parameters that a business can give to the camera, whether it's a customer walks in the door, or some suspicious activities happening in a corner, or a table has been tipped over. This is a great example where edge compute is actually helping bridge one of the problems we have, which is connectivity. If you can't imagine tens of thousands of cameras streaming 4K video over our aging IT connectivity infrastructure, this should be a great solution. Now, another great example of where our infrastructure is actually becoming more aware of what's happening in it is a company called Shotspotter, where in New York City and many other municipalities in the United States, this company is actually deploying networks of sensors that can listen in and recognize the signature of a gunshot. And using the network of sensors along with the physics of acoustics, they can actually precisely locate where the firearm was fired. And their engineers even believe that in the future they're going to be able to understand what type of firearm it was and where it was going. What they're doing is leveraging the vast network of connectivity and sensors they have to automate or autonomize the complicated spatial processes that humans used to have to do behind ballistic forensics. Now, this data deluge is enabling the autonomous revolution in tons of verticals. The most hyped is by far automotive, because I think we can all very easily relate to the challenges of driving, the spatial processes that we have to go through to understanding how that works. But just as ShotSpotter in the past has automated the complex spatial reasoning needed for understanding ballistic forensics, we're seeing the same thing happen in driving as well as other decision-making engines around the world. However, if you think about the way that it's helping humans make decisions, it is helping, but typically it's helping us make decisions after the fact. Like, let's think about one area where the big data world has definitely passed the hype cycle and is in what Gartner might call the plateau of productivity. That area is in retail. Every day, retail analysts at Nordstrom and Walmart and Amazon are getting click data, getting foot traffic data, are processing that information and helping make decisions about what products to feature, what products to demote, where to design their stores, how to place a store next. But still, this kind of information, even though it's coming in real time, is being processed after the fact. It might be 24 hours, might be 36 hours, but very infrequently is this kind of information being used to make split-second decisions. And the reason is not that difficult to understand. How long do you think it would take a human analyst to understand what to do with this particular screen grab of some retail information or analytics? I mean, it might take 4 or 5 minutes for an experienced analyst. But that 4 or 5 minutes was preceded by months, if not years, of looking at this type of information, seeing example after example of what one graph happens to have an effect on sales next quarter, and then being able to understand in an intuitive fashion what that graph means for your sales. The fact of the matter is that while we've given machines the connectivity, compute power, and the information access they need to start making real-time decisions that are on par with what humans can do, there are many types of decisions we have in everyday life that the human will have to remain in the driver's seat for. In some cases, it might just be that there's no artificial intelligence software to replace the human. But increasingly, you're going to see examples where it's important for legal and ethical reasons for humans to remain in the driver's seat. One such example of how humans have not been replaced in the past is autonomy itself. I mean, before you have level 5 autonomy cars coming out with Waymo's announcement of these Chrysler or Pacifica minivan purchases, you for years and into the future for years will have much more prevalent ADAS or advanced driver assistance systems, where you're not taking the driver off the steering wheel, but you're simply alerting them to what's going on. Now, I understand a lot of us are probably scoffing at the idea that a beeping system in your car warning you of a collision is augmented reality, but at its most fundamental, it is. It's perceiving the world, understanding what's about to happen, and when you, the human, are overwhelmed or more likely distracted by the amount of information coming in through your eyes and ears, and you miss the fact that you're about to run into a car on the highway, when it beeps, it might not be cinematic, and it might not be putting up visualizations that are registered against the real world and understand where your eyeballs are looking, but nonetheless, that beep is augmenting your understanding of what's going on and helping you make a decision in a split second. Now, I mentioned a second ago that there are a lot of other examples where the reason we're not going to be able to replace people with machines are due to the way that our world has evolved and our ethical and legal frameworks for how we understand the responsibility of those decisions. And there's no better example outside of driving than the military and in first response. This is a photo of the US Air Force Special Forces unit called combat controllers. And air combat controllers are people that have gone through up to 5-10 years of training before they can actually be deployed to the field. And their job is to go in first and basically coordinate between the ordnance munitions that the Air Force is dropping and the troops on the ground. This is an extremely cognitively demanding skill that requires that 5 to 10 years of training, because not only do they have to be FAA certified air traffic controllers, they have to understand how to describe a scene that could be very nondescript to the average person. They're looking at mountains in Kandahar province, for example, and yet still somehow communicate to a drone pilot or a pilot of an F-16 exactly what point they should and should not strike. And this type of information is very difficult to communicate over the tools that we humans have, language, paper, maps. The methods of communication and analysis that we use today is very limited, and essentially language, which is our communication protocol, is relatively low bandwidth. In fact, if you look at something like this is a scene. Now, I'm not playing audio for a few reasons, but this is a scene where you see a drone pilot looking at a potential target, and the air combat controller is coming back to them and saying, the target is a rectangular building to the southeast. Do not engage the building to the north. And now the target's in motion to the southeast, static, 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 to the north. So the payload operator in this scenario is overwhelmed with information. First of all, they have to understand what direction is the plane going in, where is my camera looking, then somehow deduce where is north, what is the southeast building. There appears to be 2 buildings to the southeast. Is that a parking lot? Is it a building? Why should I not engage the building to the north? What is the building to the north? Now the target is in motion. There might be 3 targets in motion. The amount of information coming at us through the communication channel of language is just too much for most people to make fast, efficient decisions. And yet, we're not at the stage, and I would argue we may never be at the stage, where we can truly automate the decisions that involve life or death scenarios like this. That's why we at Edgybees are focused on trying to apply augmented reality to improve the interface that we have with machines for these types of decisions every day. It's not just in the military that you have a life or death decision you have to make that can be extremely confusing. Every day, fire trucks go out to a scene, and there'll be a separate truck that brings along the battalion commander to determine who to send in, who's in the building, where to direct water, when to call for backup, if in a wildfire scenario, the fire has broken the fire line. And today, the vast majority of this is actually conducted around a whiteboard in the back of the truck. And information is added and taken away from the whiteboard. I've seen this happen now in California and in Texas on product tours. Information is added and subtracted based on the information that they get on the radio. So again, we're relying on voice as the method to communicate the information upon which we make these decisions. Not only voice, but it requires a lot of trust, because the person, the battalion commander making the decision, isn't actually seeing what's happening. He or she is seeing what somebody else is seeing and relaying to them by voice. At the end of the day, what we're dealing with is a very reduced ability to make mission-critical decisions. So this is another example of the kind of, I would call it low bandwidth communications. If you're given some information about somebody with difficulty breathing on the side of a sidewalk, but you're just given some coordinates, it takes many steps to then translate that into a Google map, to translate that into directions to drive your truck, to translate that into, where on the corner are we? Are we looking at the northwest corner? Is he or she across the building from this parking lot, et cetera? So what we've done at Edgybees is tried to move all of these decision-making processes into a much better framework by introducing augmented reality, especially augmented reality from aerial video. And we believe that by moving something from what you just saw on the screen here to what you're about to see now, you're going to help mission-critical decisions be made with more information in less time and ultimately improve outcomes for people, whether they're firefighters, police departments, or in the military. Our technology actually evolved, funny enough, and in reference to the title of this talk, out of the gaming world, where we introduced a game called, well, the application today is called First Response, but we introduced a racing game where you could fly your drone around. And we were approached by fire departments from around the country, as well as the Chinese drone giant DJI, that came to us and said, can you actually move this gaming technology into the first response world? And what you just saw was actually the result of this. We're able to take aerial video from a drone, a consumer drone with relatively low-cost components, and augment on that video critical information about infrastructure, the location of first responders, and other real-time information that helps people make better decisions here.
In 2011, we suffered one of our greatest wildland firefighting seasons that we'd ever had in Texas. I recognized then, in that pursuit of technology, UAS would be phenomenal to be able to get that aerial view of the fire, where the fire is, what's ahead of it, where our firefighters were, and to be able to track the firefighters more efficiently, coordinate our efforts, and keep them safer.
In firefighting, the main thing is to get situational awareness. First response from Edgybees enhances the capabilities that we already have from drones. So if you were looking to try to figure out what streets to route an engine or a brush truck in or something like that, that's available to you from the air rather than having to try to decipher it, what you're seeing in the visual, onto a map. It just adds the information right on top of it, and you can make decisions quicker and better.
So I look really forward to the next 5 years and where the future brings us and making us even safer as firefighters and responders.
Now, there are many reasons that we cannot automate today the processes that battalion commanders go through every day when they make a decision whether to send somebody in, whether to pull somebody out, or whether they're going to predict a building is going to collapse or not. Part of this is that there's not the software available to automate the decisions. But in the future, even if there is, I believe those are going to be decision support systems, and that we're going to have to keep humans in the loop. So what we have to do in the short to medium run is not focus exclusively on automating these decision-making processes, but actually focus more and more on figuring out how to better interface the human decision maker with the information he or she's going to be using. So I'm going to run through really quickly some of the stuff about our application, and I'm happy to take questions about augmented reality in general, what we're doing, et cetera. We're a situational awareness tool, as I mentioned, for people in the military as well as people in first response organizations. We're currently being used today by fire and police departments around the United States. And the vision in the future is to go way beyond aerial imagery and to actually apply our technology to have augmented reality on CCTV cameras, on body cameras, on dash cameras, so that at any moment, somebody can take a feed of information and instantly understand what they're looking at and make a faster, better decision about what to do in response to that. In the very beginning of the presentation, I mentioned that one of the things that we humans have, one of the things we're struggling with is how to process the immense amount of information that's coming at us. And this is just going to accelerate and get much more problematic into the future because of the amount of information that especially buildings and smart cities are producing. This is a screen grab of a visualization of a key, I would call it a tier 1 vendor for building safety and fire and police equipment in the United States, showing what their future vision is for equipping buildings in the future to have information that feeds back into fire departments when they respond. So I mentioned that we actually started as a gaming company, just to give you a sense of what it looked like before we turned into a first responder application. This was it. This was Edgybees about a year and a half ago. And it's kind of funny how we moved from entertaining people to hopefully making better decisions in mission-critical scenarios. I'm happy to take any questions.
Awesome. Thank you very much, Prescott. We do have a question up on Slido.
How are you able to add on AR content in real time? For example, if a new individual shows up on scene, how does your software account for that? So today, we do two things in the software. One is we localize the camera, and we do a little bit of scene understanding to help actually reinforce the localization we're doing, which is primarily through telemetry today. Your question about how do we identify an individual on scene, there's two ways to do this. The first way, and we talk, because we work in the military and because we work with first responders, we talk in terms of blue team, red team. Blue team are assets that you know that are part of your team and that you understand because they're sending information to you. In the case of a blue team asset, such as a firefighter in a wildfire, you're getting very precise information on who that person is and where they're located because it's being sent to your systems, and therefore we're able to display it with some degree of certainty. Now, in red team scenarios where you're dealing with assets that you don't understand, but you see in the scene, we're relying both on internal image processing and scene understanding that we're doing, as well as we're going out to the ecosystem of people that are producing great SDKs to do full motion video scene understanding and object identification, and we're layering in that information. So essentially what you get is a single pane of glass through which the fire department or through which the aircraft operator is able to see the scene, able to see blue team assets, and able to rely on external technology providers that can do object detection, understanding, and then display that into the scene itself. What aerial platforms does your tech support today? So we started as a gaming company, and as such, we started up on consumer technology platforms. So DJI drones, the Spark, the Mavic. We then moved into public safety. Serendipitously, we were approached by people in the public safety realm. And today, it's dominated by what many people consider the most sophisticated, most advanced, low-cost drone provider, which is DJI. It started as a consumer drone provider, now is the leader in the world of commercial and industrial drones. So we work on a wide array of DJI drones, and today we're in the process with partners both in and external to the military to port this technology to work on drones ranging from the General Atomics Reaper and Predator to hopefully even larger drones like the Global Hawk from Lockheed. What sort of tracking technology is being used? So the key about Edgybees is we consider ourselves the visualization platform. So we are able to localize, geo-register, and display information on a video stream. And we rely on an array of technology partners to feed information into that. One of those partners is Motorola. Actually, Motorola is one of our Series A investors. Motorola is on the cutting edge of what you would call indoor location positioning systems. And whether they're using technologies like beacons or even technologies further out there, they're developing a range of approaches to identify where somebody is in a building. This is especially critical in the fire realm, where you don't necessarily know the risk-reward scenario before sending somebody in to try rescuing an individual. Or all the time, firefighters get lost within a 5, 10-story building, and it's hard to understand where do you go to extract them. So Motorola and other technology providers like them are helping feed in the information that we can then visualize to allow people to make better decisions. Next question, where does the processing happen? Drone, base station, or cloud? This is a great question, and it's actually at the core of why we think Edgybees is being chosen as the platform, even though there are other vendors out there that have, perhaps I would call it more cinematic augmented reality. The reason is that we have a very distributed architecture. We can take video, even if it's, we're dealing with latency of 200, 300 milliseconds, we can still process that video on a low power edge device, such as an iPad or even an iPhone 6, and provide a sufficient level of geo-rectification for us to overlay things in a way that's still usable. Now, we also have a cloud component. If the viewer of that video, say a battalion commander, wants to highlight something in the video, he or she can circle on their screen, and that circle, the circle they make on the screen is actually geo-registered as a polygon that sits on the earth, and that polygon is shared through a cloud instance to any other people that are watching their same mission. So there's a there's a low power edge component to the actual processing and the augmenting, and then there's a cloud component to the sharing and the communication and collaboration aspect that happens over that video. Next question, how do you want to plan to overcome the traditional challenge of interoperability between first responders and different jurisdictions? This is a great question, again, because it's something that I think is why Edgybees is being used and selected by fire departments and police departments. I can give you an example. The city of Gainesville, Florida is in Alachua County. The county sheriff is currently using Edgybees because they call it the Google Docs of geo information. You can, in a secure way, press one button when you're running a mission and you have your drones out generating video, generating markers on the ground of incidents or information you want to record, and you can, in one button, share a link to somebody else around the world who can jump into whether it's a Google Maps interface or to actually the drone video itself and see what you're doing. So interoperability, it's a big challenge, and perhaps just going over the top and providing links on the open web will come up with a lot of problems, and we will address them as we have to. But it's the fastest way we've found to allow departments to communicate with each other, which solves the biggest headache, which is people get lost, people don't know what's going on. It solves that headache. Time for one more question?
Yes, take that one, and you had a question up there as well.
Sure.
And we'll wrap up.
Have you done any work in the construction industry? As of now, we've spoken with a few major contractors. We have not gone and done any serious work there. I can give you one scenario that I know we're imagining right now. Imagine you are flying around a scaffolding of a building or a rig. You actually frequently have that information in BIM, Building Information Management data, where you can sort of model out where the scaffolding is and what it looks like. If you're flying in a low visibility scenario, you might not be able to avoid hitting the scaffolding, but if you can use Edgybees AR to actually visualize where the scaffolding is with essentially a wireframe framework, it almost gives you what the aviation or the avionics industry calls a combined vision interface, where you're looking at a relatively dark scene because you might be flying at dusk, but you're also able to see augmented reality on top of that scene to help guide you around certain obstacles. And somebody here had a question.
Yeah, two parts. One is, do you have a formal relationship with Esri? And second of all, so I ran NIMS and emergency response with the City of Austin Situational Operations, and we got real-time data from satellites. That is exactly what we use. The drone may be for something if we want to get up close, but almost everything I'm seeing and what you do, we already did that with satellites. So what's the advantage of using the drone side rather than satellite data, which that satellite data was only 2 or 3 hours delayed?
Sure thing. So there's two parts to your question. You asked, what's the advantage of using drone footage when you actually can get satellite imagery 2 or 3 hours delayed as you did in the city of Austin? And remind me as formal relationship with Esri. We don't have a formal relationship with Esri. We'd actually love one. I think that Esri is by far the leader in GIS information management. And a lot of people in fire response, especially when it comes to pre-planning incidents where they're trying to see what would we do in response to X, Y, or Z scenario, they're doing that on Esri. To your question about using satellite imagery, we have no problem with using satellite imagery. As long as the imagery can be geo-rectified through Edgybees, we would allow it through our interface. Now, to your question about people that are already using Esri to have geo-rectified satellite imagery, it's now slowly changing with the introduction of companies like Planet Labs, and I forget the name of the second company, but it's another company that Gates seeded and has been going out now doing full motion video off of low Earth orbit satellites. 2 or 3 hours is still enough delay where in a wildfire scenario, you'll have a break, and that break could have gone a kilometer in 2 or 3 miles, 3, 4 kilometers in some cases. So you do actually need up-to-date information, and even though a lot of our use cases have been on drones thus far, we don't consider ourselves a drone company. We are an augmented reality company. And so we're happy to work on any sort of imagery source, including non-LOP imagery, like SAR radar video feeds and whatnot, we can do.